Discovery that changed physics. Gravity is not a force. One of the four fundamental forces at work in the cosmos is gravity. It is unique among the four natural forces, yet no other force is quite like it. Actually, gravity isn't a force, or at least it may not be a force in the way you understand it. If you think you have a firm grasp on the concept of gravity, you're in for a shock. According to Einstein's general theory of relativity, gravity does not act as a force, and gravitational fields do not exist. Hello everyone and welcome back to our channel. We are back again with a classy topic. Is it true that gravity doesn't exist? If you're new to our channel, please subscribe to it by hitting the bell icon. And now, let's get started. Gravity is a force between masses. The number on a scale symbolizes the Earth's gravity pulling on your mass, giving you weight. The sun's gravitational pull keeps the planets in orbit, as does a black hole's. Pushes and pulls define forces. Gravity is only part of a more complex process explained by general relativity. General relativity is an ingenious theory, but it rejects gravity as a force. Einstein's theory is an unusual assertion, therefore it requires remarkable evidence. Several experiments confirm space and time's curvature. Everything in a gravitational field falls at the same rate, proving general relativity. On the moon, a hammer and a feather will hit simultaneously. The equivalency principle holds for any object, regardless of mass or composition. Since everything falls in the same manner, a free-floating spectator far from gravitational sources and a free-falling observer in a huge body share the same experience. Space station personnel look weightless. On the space station, Earth's gravitational pull is nearly as powerful as on Earth. The space station is plummeting, though. In orbit, the space station falls around the Earth. Einstein developed his idea by equating floating with falling. Gravity isn't a mass-based force in general relativity. Gravity is caused by mass distorting space and time. Objects move straight without force. If you twist or bend a drawn line on paper, it won't be straight. When space and time bend, so does an object's path. This explains why all items fall equally. Gravity warps space-time, thus all straight routes bend near Earth. What experiment could prove gravity warps space-time? A close bulk can deflect light. Since light has no mass, gravitational force shouldn't deflect it. False. Newton's gravitational theory predicts that nearby mass will deflect light since light contains energy and mass and energy are comparable. GR expects twice as much deflection. The time delay experiment is another proof. The light near the sun isn't perfectly straight because the sun's mass warps space. It takes a longer curving journey. This means light from a planet opposite Earth arrives a little later than expected. Earth's radio transmissions rebounded off Venus while the two planets were opposite the sun. As predicted by general relativity, the round-trip delay was 200 microseconds. This effect is called the Shapiro time delay, and it means the average speed of light, as defined by journey time, is slightly slower than the instantaneous speed of light. Third, gravity waves. If stars distort space, the motion of stars in a binary system should cause space-time ripples like spinning your finger in the water. As gravity waves radiate from stars, they drain the binary system's energy. This effect's called enspiraling. As the stars spiral, their orbital period shortens because their orbits shrink. The impact is too tiny to notice in ordinary binary stars. Taylor detected a pulsar in 1974. Pulsars are neutron stars that emit radio pulses. Pulsars have regular pulse rates. Taylor found this pulsar's rate sped up and slowed down often. This variation was caused by the pulsar's orbit around a star, and they calculated the pulsar's orbital period to a fraction of a second. Over time, they detected their pulsar's orbital period shortening. As predicted, gravity waves are enspiraling the pulsar. Last, frame dragging. This effect was near Earth. The Earth's rotation bends space-time around it in addition to its mass. Frame dragging twists space-time. The lens tearing effect can measure the influence near Earth. Put a spherical gyroscope in orbit and observe its axis of rotation. Without frame dragging, the gyroscope's orientation shouldn't change. Frame dragging causes space and time to spiral, causing the gyroscope to process and shift orientation over time. Each experiment shows that gravity isn't a force between masses. Gravity is a space-time effect. Gravity shapes the universe. Hey, thanks for watching. We always try to give you some interesting information related to the universe, so please leave us your comments in the box, and we'll see you next time.